This is Team 41's second status update for Project 2. So, um, we know we're in week 4 and week 5 of the project, and we're considering that's where we're at in the project. We feel like we are on track with everything that we need to get done, including the steps on the Gantt chart and the work breakdown structure. The Gantt chart is displayed for reference. Um, we have a clear idea of the code required for the movement of the robot through LabVIEW. And also, we have kind of a clear idea of the appendage functionality, including the grabbing mechanism and how that will all work out. Some changes were made in the work breakdown structure regarding the movement um, sections and the clamping mechanisms. Uh, Ryan took over the clamping mechanisms, which is different as displayed on the Gantt chart. But we are making progress with those sections in particular, so there has been no issues there. Really, the only issue that we might face down the road as the project unfolds in the later weeks is issues relating to the detection of bins. And we floated around an idea of a QR code system on the bins that the robot will pick up and detect. But we will need to do some extra research regarding the functionality of that idea.
This will be an update of the current progress made on Project 2. Three main mechanisms have been added to this robot. Firstly, the lifting mechanism. The lifting mechanism is what lifts the container and then carries the container to its intended place. Secondly, sensors. Sensors have been added so the robot can see where it is going and detect containers. Lastly is line tracking. The robot can now track a line and follow it to its intended destination. We decided to use one motor for the lifting mechanism. The one motor shown in these pictures scoops up and presses in the container. By using one motor, the robot is more efficient, smaller, and cheaper to build. This also means it will require less parts to build the robot. We used three color sensors for this robot. Two of the sensors are used to detect and follow the line. The last sensor is used to detect the container, as well as the contents within the container. Lastly, we use two sensors parallel of each other to track the line. If one sensor detects a black line, it then tells the computer to slow that side of the robot down. This will cause the robot to self-correct back the other direction. In its current iteration, the robot can follow a straight and curved line, but the motor values still need to be fine-tuned to reduce the chance of failure and increase the speed. We will now show a video of the robot following the curved line. Because the robot is still a bit slow, this video will be sped up. What is next for our project? The next thing we will be working on is balance. How will the robot balance and how will it correct itself when balancing? The next thing we need to make sure we include is detect breaks in lines. Currently, the robot can follow a solid line, curved and straight. However, we are not 100% sure if it can accurately detect breaks in the line and still follow the path. Therefore, we will need to continue to fine-tune the code to make sure it can still follow a line even when it is broken. The next thing is for the robot to be able to go faster and fine-tune the general movement code. Currently, the robot, again, can follow a straight and curved solid line, however, it is extremely slow. We want to fine-tune all the motor values to make sure the robot can go faster and is more efficient. The last thing we're going to try to get done before the next update is QR codes versus color sensors. We're not sure if we're allowed to use QR codes, so we may put in a request for additional information about that.